Very important question. A river with D has to be crossed. So let this be a river with a width D has to be crossed, where speed of water is VW and the speed of swimmer is Vm. So to find out the minimum time to cross from point A to point B, so we have to take two cases. The very first cases is that number one, if velocity of man is greater than velocity of water. In that case, what do we have? So let us suppose that the flow of water is in this direction and the man wants to reach over here, so he'll make an angle theta with the flow of water and he'll try to swim in this direction. So to find out the velocity, resultant velocity, so this becomes the resultant velocity, which this becomes the velocity of man. So this is Vm sin theta and this is Vm cos theta. We know that to go from point A to B, time equals to total distance by displacement by time, displacement by velocity. Here displacement is d already given here, so it is d by Vm sin theta. Now to have a minimum time, so for the minimum time, this angle theta must be equals to 90 degree. So if you put sin theta 90, it becomes 1, so the time becomes d by Vm. Now number 2, the case if the velocity of water is greater than velocity of man and the man swims with the angle theta with the flow of water, then finally instead of reaching over here, the man will reach somewhere the point C. So there becomes a drift from this point to this. So we have to find out the minimum drift, how much it becomes. So here the velocity of man is Vm, velocity of water Vw. Here naturally Vw is greater than Vm. So we have effective velocity, that is effective Ve, effective velocity equals to Vw minus Vm cos theta. So already then x equals to this distance, minimum drift x equals to effective velocity into time. We already know the time is here. So putting the value of time in this equation, so we get x equals to this into d. So for the minimum drift, the differentiation with respect to theta on this equation is, if it is equals to 0, then it becomes the minimum drift. So finally if we differentiate this, so we after differentiate we get this. From here we get the cos theta equals to cos inverse. So this is the minimum angle to have a minimum drift. Putting the value of theta in this equation 1, so we get x equals to root over Vw square minus Vm square by Vm into d. So this is the minimum drift which is required.